We can drink.
All right. All right, everyone. Welcome to this user group presentation. Hold on a second. Sorry, we can chop that off later. All right. Since no one's joining anyway, we're just going to ignore my poor presentation skills. All right, I'm going to share my whole screen here. Everyone tell me if you can't see it. I have a giant monitor. I'm going to try to make all the text bigger. There we go. All right, can everyone see my screen?
Yes.
Can everyone see my screen?
Yeah, you're good, Hans.
All right, thanks. All right, welcome to this user group presentation of Remediation as a Service. I'm Hans Maldonado. Ashwin Manavanan will also be speaking today. We've built this little demo in the Nova environment. All right, so why remediate with automation? These three things kind of go together, right? I mean, more uptime for your applications and services because we're going to save time because machines are faster than humans. It's like one follows the other, right? So basically, if the concept is this, we have an application server or a database server where a critically, an important process has to be up all the time, right? In this case, it's a bastion farm, right? So users log in to one of these three Windows boxes in order to log into something more important, right? We've probably all done this. So sometimes, like one of these services, one of these important services will go down for some reason. That reason can vary. The server could run out of memory, maybe too many users tried to go through one of these bastion farms at the same time, but the first thing you are going to do, though, is to restart the service, right? No matter what the cause is, we're going to restart the service, right? So in doing this, right, I even if I ruined it, I clicked ahead. All right, hold on, let me back out of here. So even if you're just going to click a button to restart the service, right, still 0.3 machines are faster than humans, right? So now, if you're going to go, like, let's say, these servers go down and you have to go restart one of these things. I mean, you probably can't just log right onto it, right? I mean, usually you're gonna have to go in and access a jump box, and you might have to use an authenticator, right? It could be worse. So no matter if you have to do this in the middle of the day, right? Whether it's like the application monitor, the monitoring engineers, or if it's the middle of the night, right? Again, we can do this faster than a human can, right? And so all these things add up to more uptime for your applications and services. I should have put more sleep also for your engineers if it happens in the middle of the night, because what are they going to do in the middle of the night? They're just going to restart the thing, right? And probably go back to bed. I mean, maybe they have to do some kind of investigation, right? But probably not. I mean, they probably just restart the thing and be done with it, right? I've built alerts to do this plenty of times. So, all right. So that's the one scenario for our remediation as a service. The other one is going to be that we have a file server here that, big files get put onto this thing and taken off. And it needs to have a certain amount of space in order to accommodate that. So what we're going to do is we're going to yeah, we're going to kind of automate a little bit the remediation of this, because again, the assumption is if you had to like fix this yourself, right? Like someone, and again, I've built alerts for this, a very similar use case. It wasn't a file server, it was a database server where they had these temp directories that for some reason would fill up, and they would have to go and look at it because certain things they could stay and certain things had to go. So so that's each scenario here. So we're going to remediate each of these things. All right, so right now, let me just well, I don't need to refresh. Yeah, right now we're monitoring the disk usage. It's at 56%. Right, there's just one server in this service, right? And then for our Bastion farm, right, we're just monitoring the remote desktop service, right? It's either up or down. We've got 3 hosts, right? So the first thing I'm going to do, because it's going to take a little longer due to the input schedule, I'm going to throw a big file on that Linux box. Okay, so I just put a 10 gig file on there. That should get us over the 70% threshold that is needed to trip that alert. And then in the meantime, I'm going to go onto those Windows boxes and I'm going to turn off that remote desktop service on 2 of them, right? So here we'll run this get service command and I'll show you that the thing's running. Now I will stop it. By the way, is this still visible? Do I need to increase the text size on anything? Can someone confirm that? Can we still read it? I assume somebody would have spoke. Yeah.
Yeah, I can read it.
Okay. All right. So anyway, we just stopped it. I'll run this get service command again, and we can see that it has stopped on 2 of those Windows boxes. All right. So now it becomes a waiting game. Right. I've got all the inputs, most of the inputs and scheduled searches running faster than would be common in the real world. Most things are running on either 1 or 2 minute intervals here. And that is not realistic. I mean, your inputs are probably going to run on 5-minute schedule every 5 minutes, and then your KPI searches probably run every 5 minutes. So, you know, that's much more common. All right, so we'll just have to wait a few moments. But basically what's going to happen, right, is as soon as either of these alert conditions are detected, right, so right, once this shows up in the screen that I'm showing you now, there are still a couple other alert generating searches that have to run. So it'll take just a few minutes even after that, but the fastest this could happen in the demo, this could, I mean, I've seen it happen in like 3 or 4 minutes, depending on how, you know, depending on when those searches run. But in a real world, it's more like 10, 15 minutes sometimes, especially in a big ITSI environment, right? It's yeah. Okay, so we see that this has been detected now, right? So now we're registering critical disk utilization, 76% full. We've set the threshold at 70. So now we have, right, we got a couple of minutes to wait, but it looks like this one will probably be running ahead of schedule compared to compared to the other one. The inputs are running faster on the Windows side. They're running every 5 minutes on that window, the Linux box. Okay, so we see that we've now detected that the service is down on 2 of those boxes. So let's just wait a minute. All right, I'm assuming both of these things are going to happen pretty much simultaneously because the the KPIs that detect these different conditions, those run on different schedules. The inputs run on different schedules, but the alert generating searches, the searches that are going to create an episode here and then eventually reach out to SOAR and kick off those playbooks, those things run on, those are all the same, right? It's one alert generator. Yeah, it's the one search. Well, it's 4 searches, but all 4 searches each applies to really any alert condition that I would set up in this environment. That's the beauty of, so while we're waiting for that, so the elements of this, right? We have ITSI, obviously, but the content pack for monitoring and alerting is by far my favorite content pack because it works so well out of the box with just a few and it's easy to modify also. The complicated parts you don't need to modify usually. But yeah, so we, in it, oh, come on, I went back. All right, so we got that. We've got the content pack, and then I have a custom aggregation policy. It's a custom alerting policy. And then we've got a lookup that I added, which allows us to basically insert this remediation as a service. We could stick this into an existing environment full of other alerts and actions, and I could hook into the again, like assuming that the other environments are also just using one search to cover many services, if not all, because that's basically what you do with that content pack. You run, you don't run an alert for a particular service or a particular KPI. You scan all of your KPIs, all of your services for an alertable condition, right? You scan them all together, and then you take, the dynamic information from the event, and that's how you then, reach out and do one action as opposed to another action, right? All right, so we see here the first event in our episode has happened. I'm sure we've got one on the other side too, because again, it's the same. So we've got 2, right? 1 for each server. So the first event is, we'll take a look at some of these correlation searches. Again, there's 4 of them. There's one that first alert is detected by one of them, right? And again, imagine a big environment. We're scanning all the KPIs, right? For and again, you can control, like when I say an alertable condition, you can customize this. Like it doesn't have to just be critical, right? You could pick one service and say, I want to alert when this is medium, right? And again, if you know how to customize this content pack, right, you can put a lookup in place and customize that. So you could basically allow the different teams to set different, right? If one team doesn't want to alert it critical and they instead want to alert it high, you put that in the lookup, right? All right. So the first correlation search that goes, well, that generated those initial events is this one, the service monitoring entity degraded. So it's looking for an entity, usually a host, whose KPI is degraded, right? It's only going to alert if you have KPI, or I'm sorry, entity level threshold set. So if you just set a threshold on the KPI, this search is not going to cover it. It's looking for, host level. And the way that there's 2 things I've put in this to customize it. So basically, I added that line because I've decided that this is a search that from which I want to generate alerts, right? And that could just be an alert, or that could mean an alert plus, like reach out and do something with SOAR, or generate a ServiceNow ticket or something else, right? I've also added this urgency of 11. And in that way, if you have a KPI where you've set the importance level rather low, I'm not interested in those, right? We're only like, so what that means is you could go through and have a bunch of KPIs. Like you could set a critical threshold for CPU utilization, right? You could say, if CPU reaches 90, turn critical. Now, I would advise against that, but you could do that and still not alert on it, because you could drop the importance of it, which would make sense, right? If you want to define higher critical for CPU utilization, right, you probably should come here and you drop the importance level. All right, I see we got an email notification. So let's we'll come back to that search in a minute. So I'm assuming that things are back up, right? So if I go, well, we're not going to go there. So if I go back here and I look, see if that term service is up, I see it's running now, right? So let's go look at our episode here. Because within the episode, we're going to see a trail, an audit trail, if you will, of the fact that Splunk reached out to SOAR, SOAR did something, and it was successful. All right, we have 2 episodes, one for each server. An episode being a group of notable events which are related somehow, right? So we see here, see the first alert, and we see that an alert was triggered. I'm here to the activity tab, and we see these 4 lines, and this is this is kind of the alert, the audit trail of the alert. Right, first this one happens, then this, then this, then this, right? We already know this worked because I just checked via the PowerShell prompt. Right, you'll see the same info over here. Again, because it's a single policy that's doing both of this. And actually, if you see in here, you see we've got a link to the SOAR machine. And we just did a standard config to make this happen, right? There was nothing I had to customize to make that show up. It just is there. And that will take us right to the SOAR server. I'll let that come up. We'll go there in a second. Maybe I should quit bouncing. Let's stick with that. So we'll come to the SOAR server, right? We see, a couple of containers. Pardon me, Ashwin, if I get my terminology incorrect, but so here we've got the alert that came from ITSI Splunk. See, we've got a bunch of raw data within this alert, including an important piece of information. Let's see, source IP, source address. That's what I'm looking for. Ashwin, help me out. What shouldn't I see it within this?
Okay. So you close this, Hans.
Okay, am I not going to see the IP in here?
No, scroll all the way up and close this. And do you see artifacts on the top right next to timeline? If you go a little right, yep, the same line.
There you go. Okay.
Click on artifacts and click on your episode monitoring. And if you scroll down,
all the way.
Yep, you should see source.
There, source address. So right? We have two different IP addresses for those machines, and I'm feeding them. This is custom also. We'll get back to this, right? This does not come automatically in that alert. And it's reusable code. So I'll say that it's quote easy to get it out of ITSI, but it's not easy if you don't know how to get it. So anyway, we're feeding that IP address into SOAR so that when SOAR reaches out, right, it reaches out to that machine. All right, and so the same thing happened for both those machines. And here, let me pop over to the, because I will give that time to get fixed. Because those episodes are going to go away, right? Because again, the content pack, if you just basically turn it on, it's going to automatically close those episodes after it detects that the condition has, the alert condition is gone, right? All right. So here's the email Ashwin sent me based upon that detection of disk overutilization. And the first thing it did automatically is just wipe the temp directory because, I mean, I have seen, things get left in the temp directory that, shouldn't be there, right? Like development artifacts, as I call them sometimes. So we're just going to wipe it because you really can't have any expectation that you are going to keep what's in that temp directory. So we wipe that out. And after we wipe it out, we end up with, this much disk space left. And then we also run a check to see, are there any other files greater than a certain size on this machine, right? You could vary this, right? You could check a certain mount point, which actually we are checking the root mount point. But here's what we get back, right? Here's all the big files. So production stuff should probably stay, but here we see like a bunch of personal stuff. So, if I'm the analyst at 2, honestly, it doesn't matter what time it is. Again, I can respond to this email faster than I can log on to this box and investigate, right? Even if you have the command, like, the exact command you're going to run, right? So I'm going to just reply to this email. And so we're going to request that all that personal stuff go away. On. Right, we'll just leave it at that. We'll delete, request those 3. We could go through and finish, right? But anyway, okay. I'll respond like that to the email. I'll pop back over to. By the way, there was a fellow, this person, Karthik, gave a conf talk in 2019 where he described this conceptually, but there was no demo like this. There was a kind of a concept talk. Right. Yeah, I'm not going to click into the episode on that file server one because it's pretty much the same thing. Right, it's the same thing that we saw in the Bastion farms. And we see here like that episode's actually already gone because Splunk has already detected that the disk utilization. Matter of fact, I think the disk utilization alert would have been resolved simply by wiping the temp directory. Got us to where we needed to be, right? And then, and same thing you'll see here on the Bastion Farm services, right? Services back up on all the machines. Episode has automatically. I don't believe it's. I don't know if it'll be closed yet, but it's certainly gone back to, the severity of the episode has been updated, which is why it's right. So it's no longer critical, which is why it no longer shows up here, but I bet it's still open. Because out of the box, I think it would, the content pack would probably leave these things open for a few minutes, like 20 minutes, I think. Like, so once the alert has gone back to normal, it updates the severity of the episode. And then if it stays normal for a given period of time, it'll close it, right? You see it's still open, right? Status of this is still open, but here and very shortly, this should close it. I forget how long it actually goes. But back to, how do we get that IP address? Like, and how do I customize that content pack? All right. So to get this functionality, we need these 4 searches turned on, right? Entity degraded, degraded service or KPI goes back to normal. Let's see, this one sets episode to highest alarm severity. So that will actually, that changes the severity, right? This detects that it goes back to normal, but then this one will actually edit the severity of the episode. And then here's the one that's checking for that alert attribute, right? So these 4 have to be turned on, right? This eval alert 1, this is the alert attribute that this search is looking for, right? Notable with alert attribute, right? Because when you run this search, right, all of this, the results of this go into another summary index, right, which then gets checked by that search we were just talking about, right? So that's how the eval alert 1 has to be there. And you can put, and again, you can customize this too, right? You can have different alertable conditions, like send an email, like alert underscore email equals 1, alert underscore SOAR action equals 1, like, and then again, you can use lookups to allow teams to customize it. All right, but okay, so the IP address. If I don't have this line here, basically this chunk of code, right? I'm first checking the entity list, because in my entity list, I have got some metadata about the entities, right? So this is like your inventory of an ITSI. You would have all of the important hosts, firewall devices, it could be storage arrays, right? It's whatever the important things are you're monitoring are going to be in your entity list. So there is a way to access that list, and then this you can honestly, you can probably find this search or variations of it online, but I've added the IP addresses as a metadata field for those entities, and so this is how I get it into that alert. Because if I, that info does not get, it's not written to the summary index by default unless you put it in the event. Then I have 2 other lookups that I added. Just a little, I'm not going to focus on it, but like ITSI no longer consistently writes service name to the summary index. Sometimes it does, most of the time it doesn't. So if you want to search the summary index and use service name in any way, you have to access this lookup and grab the service name. But this lookup is what I'm using to like, and this is how I would insert this functionality into an existing environment. Yeah, let me just call the lookup. But I used the lookup editor to build it. The lookup editor should be like, dang, I should almost include it in as a default app when Splunk gets installed. It should be there. So in this lookup, I put the name of the KPIs that I want to, use for that I want to monitor with this remediation as a service, right? I can turn it off, right, if I wanted to, right? So I've added an on-off switch. I've added the service name because we could have these same KPIs appearing in other service names, but perhaps we don't want to alert on this same KPI in the other services. Maybe we just want to alert on it in this one, right? So our lookup, right, it has to match on both. It has to match on service name and KPI. And then finally here, I'm applying the SOAR playbook label because, well, let's go see why. All right, because I have to have that. All right, so that's the correlation search that really kicks it all off. And I don't actually really think I modified the other ones. I'm trying to see here. No, I don't think I did. Let me just double check. I don't think I touched the other ones in terms of modifying them. Other than to make them run more frequently. I think they run by default every 5 minutes. I'm running them every 1 or 2 minutes. Okay, yeah, I don't believe I modified the other ones. I just turned them on. But here's the other thing that there's one of the other pieces required. The notable event aggregation policy is how that is how these things get grouped, right? That's how I've got an episode where I'm grouping alerts according to the host, basically is what we're doing here. And
Hans, let me do a quick walkthrough of the SOAR part of the remediation as a service.
Okay.
Say show like.
Do you want to control the screen?
Yeah, let me share the screen, and I can. Are you guys able to see my screen? Yeah. So as like Hans, was showing us earlier, like every notable event or a safe search from Splunk gets sent to SOAR as a container, and each container has like artifacts of like whatever we are sending, like the set field value pairs. For example, this is like the email container that was received from Hans's response to the memory use case where we're going to delete some files, automated delete. So you can see the email artifact. We can see response of Hans to the email, the original email, and we scroll down, we can see the to address, from address, and all the other set value fields. Another important part in these containers, the label. So if we can see like multiple labels here, like mail, memory usage, and restart. So in SOAR, whenever a container with a label, particular label comes in, it kicks off a playbook that is assigned to run on those labels. So if I go to the restart service playbook, this is the workflow that was used for restarting the service on the Windows machines. And if I want to go into settings, you can see it operates on. This is the operates on is where we mentioned the label, and here it has the restart label. So once the notable event with the label restart was received, it kicked off this playbook, and it went ahead and checked for the source address and whether it's a Linux instance or a Windows instance, and based on it, it restarted the service. And everything was automated in this process. There was no manual intervention in any of this workflow. If I go back to the container, this was received as the, if you can see here with the restart label. As soon as it was received, it went ahead and checked for it and executed the, and check another, it executed the command, which was executed, the endpoint at which it was executed, and we can see it was a success. If in case there was a failure scenario, we have a like an option to add like a failure message to the container, after which we can identify why the failure had happened and if there's any connectivity issues or etc. So we have both ways. And similarly for the memory usage use case, once the playbook, once the container was created, it reviewed the contents of the server. Let me pull it up. Yeah. So it reviewed the contents of the server. So in this, currently in this user group demo, like we are just like going ahead and clearing the contents of the temp folder and then checking the memory available and then finding the list of files that is above like a certain uh, memory. Like for example, here 800 megabytes. We can also add a condition like if the server is above 70% memory utilization, we can modify this as per needs, is what I'm trying to say. And if I go back to the, so you can see here, once the container was created, it executed the program to get the memory usage. Then it did a temp cleanup, cleaned up the temp. Then again did a memory usage like command to get the results after the temp directory was cleared. Then the file size check is where like it runs a command to get a list of all the files that is above 800 megabytes. And here we get all the lists over here. And then we send the email to Hans. And we saw like, Hans responded to the email, and the email response was again like ingested here into as a container. And once it came in, it reviewed the email body in the email body part one, and it found like these three files to be deleted. And then like it deleted the three files. You can see it was like delete file code was run 3 times. And then an email was sent to Hans mentioning that these files were deleted from this instance. So all this process has been automated, and even the email ingestion, we're using like an IMAP app to pull the emails into the store part to do the ingestion, and this comes in with a mail label which executes this file deletion playbook to get the list of files to be deleted, selected by the analyst and everything. So the only part here that we need human intervention is for the files to be selected, and other than that, everything was just the SOAR doing its action. If there's any failure in any of the scenario, we have a backup of like notifying the analyst saying that this process has failed, and also like to update the container saying this action has like failed due to this reason. So that's what I wanted to cover, and why the label is very necessary, because Hans had mentioned he has to attach the label to the notable event. So the label plays a big part in executing all these playbooks. Back to you, Hans.
All right. Let's see. Okay. So all right. So Ashwin was talking about the labels. You can see how he is utilizing them at the point of the source server. So I have one, like, again, this is the this content pack provides so I think just the 4, right? Probably more, right? But this is one of the aggregation policies provided by the content pack for monitoring and alerting, where it's going to group your alerts by source, right? So to translate, SRC is the SIM field, right? But that translates to host, instance. It could be source IP, right? Depends on how you're defining your entities, right? It could be, right, again, it could be like a disk array, right? It depends, but we're grouping them by source. And just a couple modifications to this, really. But remember, in the I have that lookup, right, where I was applying the label. It was in the lookup, right, and the label is being applied according to the, right, you saw the service, the KPI, on-off switch. Let's see, I didn't change anything here for the filtering criteria and instructions. I added 2 rules, right? Actually, I added 1 rule, modified another. This one at the top was already here, except it didn't say send to Splunk SOAR for the episode, right? When this comes out of the box, all it has is add a comment, right? Alert action taken from episode monitoring, right? Which implies that, and it doesn't just, I'll say it implies, right? But it means that this is the action rule that they want you to use to then take some action, right? Alert action taken, that's just the comment. But so here you come in and give it an action, right? So depending on what, okay, yeah. So if you add other content packs, other apps and add-ons, like the add-on for ServiceNow, add-on for BMC Remedy, there are other enhancements that can be added to this list of actions. But for our environment, this is the only one that's not out of the box. So when I configure this, there's no way to, at the moment, to read this from the raw event, right? Like a lot of times for these actions, you can put in a token, which will represent something from the raw event. But for here, I have to hard code memory underscore usage. But remember, I'm applying memory underscore usage, like very specifically to specific KPIs, specific services with that lookup. And then here, what this, think of this, this is literally a search. So behind the scenes, there is a search that runs and applies a whole bunch of logic. You control the logic through this GUI. So I'm saying all the only things I added were these 3. Right, what I'm searching for is alert equals 1. I'm looking for that on-off switch, RAS enabled, and then I'm looking for the SOAR playbook label. And this, right, this search runs all the time, and it checks all your services. It doesn't. When I say it runs all the time, I believe it runs every 1 minute by default. You can adjust that, and sometimes have to in bigger environments, or as you add load to the environment. So I have and so then after I modified that one that was out of the box, I added another rule, copied all the same information, except right here, I changed the label that I'm applying. I throw on the restart label. And I also, changed which label I'm looking for in general, the restart label, right? So we could add more conditions for more to run different playbooks. And again, it's still one search, right? So this is how this would scale. This is how ITSI scales. And I think that's all I have. Are there any questions? Or Ashwin, do you want to, I don't know if you have anything, Ashwin?
That's it from my end. Any questions, guys?
Nothing from my end.
I could not hear that. I'm sorry.
Oh, nothing from my end, Hans.
Oh, okay. Okay.